Computational Toxicology Communities of Practice. My name is Sammy Hamp. I'm a Student Services Contractor here at APA NCCT. Today we'll be hearing from Dr. Maureen Gwinn, Senior Science Advisor here at NCCT, and Dr. Paul-Friedman, a toxicologist, about the accelerating the pace of chemical assessment through international collaboration case studies. Before we get started, I just want to ask that everyone please mute their lines. If you're having trouble accomplishing that, you can do that by hitting #6. And if you have any issues with the audio, please let me know in the chat, and I will try my best to get those resolved for you. Without further ado, I will hand it over to Dr. Maureen Gwinn.
Thank you, Sammy. And thanks, everybody, for joining today. I'm excited to talk a little bit about this initiative that we started a few years ago here at the US EPA. And we have an upcoming meeting that we'll try and touch on at the end, just so people are aware of it. So as Sammy said on the title, it's Accelerating the Pace of Chemical Risk Assessment. Our outline, no, that's fine. You can go forward. The outline on the next slide is just a brief outline of what we're going to talk about today. And so I have the easy part. So I'm going to talk about APCRA and the participants, a little bit of the history, and a general overview of the case studies. And then Katie's going to do a deeper dive on two of the case studies, the retrospective and prospective case studies that she's been playing a leadership role on for both, and go in a little bit more to the science, so it might be a little bit more interesting than some of the background I'm going to do. Next slide, please. So what is APCRA? It is an international governmental collaboration that brings together governmental entities engaged in development of new hazard, exposure, and risk assessment methods and approaches for their chemical evaluation activities. So what we were trying to do when putting together this sort of consortium is to bring together international regulators to talk about the progress and barriers in applying these new approach methods to any sort of stage of their chemical evaluation activities, whether it was screening and prioritization or full-on quantitative risk assessment. And then in discussing those progress and barriers, we decided we also wanted to continue moving forward and discuss opportunities to increase collaboration in order to accelerate the pace of chemical risk assessment, so hence the name. Next slide, please. I know there's a little bit of a lag. There you go. So the participants, just to give you a sense of how this has been sort of developed, starting with the first meeting in 2016, we invited international regulators, as I mentioned, and we also included a few of their sort of research support staff to get a sense about the development of the new approach methods as well as the implementation and use. The list here and the pictures there are from each of the face-to-face meetings we've had every year. But, you know, from the U.S., it's been largely US EPA, Cal EPA, NTP, and CPSC. This year we also have included FDA as well. We've included Canada, Europe, Asia, Australia, and then OECD has always been participating as well, in part because we see APCRA as sort of potentially an incubator for activities that might end up going through OECD for further dissemination. Next slide, please. So this slide just shows a little bit of the history. As I mentioned, we started APCRA in 2016, hosted by the US EPA, largely the Office of Research and Development and the Office of Chemical Safety and Pollution Prevention. I'm sorry, blanked on the acronym for a minute. The 2016 event was in Washington, D.C., and that when we first did this was going to be a one-off meeting just to sort of identify where people were in trying to use new approach methods. From that meeting, we decided to do some collaborative case studies, and so we've continued on every year to have ongoing case study works for individual teams, but also group teleconferences to get updates and have some discussions on some of the issues, and then face-to-face meetings every year. The second meeting in Finland was hosted by ECHA, and at that point we decided to sort of have a tri-lead, so it's been led by EPA, the European Chemicals Agency, or ECHA, and Health Canada since 2017. This meeting theme was continuing the collaborative case studies, but we also realized we hadn't really talked about the addition of new approach methods related to exposure analysis. So we included discussions on that and also added a few case studies related to that topic. For 2018, the third meeting, we again continued the discussions about the collaborative case studies, but we also started focusing a little bit on how to establish confidence in the use of NAMs, both in terms of comparing to traditional methods and then also how to integrate divergent data streams. And then, again, as with the first and second year, we realized we've been really focused on human health and not eco-health or assessment. So we've included some discussions on that, and we have some new case studies being proposed in the eco realm as well. So our next meeting is being hosted again by the US EPA, and it will be held in North Carolina at the RTP, the Research Triangle Park campus. And it will be held in 2 weeks, October 9th and 10th. One of the things we did last year for the first time was have a public outreach sort of session as part of the workshop. What we're doing this year is we're having our face-to-face workshop, and it will be followed by a public outreach sort of update. And so we haven't set the date for that yet, but we'll be sure to let people know and put it on the various listservs so that they can listen into any of the updates on the case studies and sort of where we are now with these workshops. Next slide, please. So I've talked a bit about the collaborative case studies. We, again, as I said in the first meeting, we decided this would be a good way to go forward to try and advance the use of NAMs. We had somewhat limited criteria as shown here, just that we wanted something that would promote collaboration and dialogue across international lines and that would address a scientific and regulatory need for a variety of the participants. So we all work in different regulatory contexts, but there are some overlapping issues that we deal with, and so that's what we wanted the case studies to sort of address. And we wanted them to, again, include international partners so that we were getting that sort of variety of context and issues and support. Next slide, please. So this slide is just a very brief overview of some of the case studies we have ongoing with APCRA. I've broken it down into sort of topic areas, which include the application to risk evaluation, application to chemical categorization, and application to exposure evaluation. As I mentioned on an earlier slide, we're also starting to include ecological risk assessment topic areas, and some of those are included in these as shown here. I'm not going to get into a lot of details on this. I think the slides will be sent to you as well, and I can share information. I think if my email wasn't on the first slide, I'm happy to share it, and we can share further information in the future. And again, so these are the sort of the general topic areas. We're not restricted to any specific topic areas, but this is sort of where the discussions have led that we have areas that we want to focus on. Again, I'm not going to go into these too much. I will say that so the next part of this presentation is really going to focus on some of the first case studies and the first to be published, which congratulations to Katie on all the work with that, on application to risk evaluation. So looking at the bioactivity as a conservative estimate of PODs, which is the first one listed here, and then the second one as well, the quantitative and qualitative comparison of NAMs and traditional animal toxicity testing for data-poor chemicals. So without any further ado, I will take a breath and hand this off to Katie to do further information on those two case studies.
Thanks, Maureen. Do we want to take questions at the end? Is that?
Yeah, I don't know if we've.
Okay. We'll take questions at the end, so if you have questions for Maureen, please hold on to those. I'm going to give you a brief tour of two case studies like Maureen talked about. I refer to them sort of reflexively as the retrospective and the prospective case studies because I think that tells you what we're aiming to achieve. The retrospective case study is really about looking back for as many chemicals as we can to ascertain whether or not NAMs or new approach methods would have given us a point of departure within the range of or less than the animal-based models. Right? So we're basically asking, would there have been any additional risk if we had done this the NAM-based way? And then the prospective case study, like Maureen alluded to, this is where we have chemicals that are data poor. And actually, we don't really know what the correct answer or correct methodology might be for determining that. And so we're trying to see if we can complete a battery of NAMs and then make some conclusions based on that. So we'll get a little bit more into them. So screening level chemical safety evaluation is going to combine NAMs because that's where we're getting our hazard prediction information, and then exposure and toxicokinetics so that we can convert those in vitro bioactive concentrations into doses that are relevant for comparison to exposure. This case study was conducted as part of a group within the APCRA, or APCRA, as I like to call it. And we recently published this first case study, and the DOI is here in the slides. It's online in draft form right now. Just edited the proofs yesterday. So, and you may have seen some of this work at SOT last year. And I don't put this slide in here to necessarily toot our own horns that we did a good job. It was more that I think the toxicology community is trying to recognize that this work is needed and that it's unique and special in that it has all of these partners listed here graphically from Singapore to Canada, right? And so that's part of what makes it a unique effort worth pursuing, because we have all of these people at the table considering their problems, which vary across geography and regulatory agency, but using the same in vitro or in silico methods to create an assessment. So why is it important to look back? I think there's a clear need to demonstrate in practical terms for as many chemicals as we can how a preliminary screening level risk assessment approach might work in a first instance. And so what we've tried to do is create something really simplistic that required very little information, that was straightforward and reproducible, so that anyone could essentially tread in our steps, create the same thing, and then kind of illustrate the state of that science, evaluate the strengths and weaknesses of doing that so that we could understand what are the important areas for refinement, and really to build confidence in the risk assessment community, where we've been using animals as the basis for protecting public health. And I think because it's public health at risk, we really need to think about making sure that we're still protecting public health if we use NAM-based methods. And I think this relates a lot to Administrator Wheeler's memo that came out, I guess, about 2 weeks ago, right, where we're talking about reducing animal methods. But to do that, kind of have to draw the line back to animal methods that we were already using, even if we don't consider it necessarily a gold standard or silver standard, whatever you want to call it. We need to create that translational step. So that's what we're doing. So the big question, and unfortunately I won't spend a lot of time in the trees in the forest today. I'm mostly going to be at this high level. But the big question is, can you use in vitro bioactivity data like what we have in ToxCast to derive conservative point of departure estimates for prioritization and screening level risk assessment? So to do that, this was our case study workflow. We took information from the ToxCast screening program, all of the AC50s for all of the chemicals we could find in micromolar units. We also had data contributed from an agency in Singapore called APCRA. They had high throughput phenotypic profiling data in 3 different cell types, and we took their in vitro point of departure information as well. We combined that data set and applied high throughput toxicokinetic models and information to get administered equivalent doses in milligram per kilogram per day. So what we were trying to do is establish a threshold dose for any bioactivity in vitro, regardless of the biology. And that created this distribution of what I call POD-NAM, or PODs from new approach methods. So you can have a full distribution, and we're really interested in essentially the 0 to 5th percentile, the lower end of that distribution, to get that threshold dose. And then the first step was comparing that back to the traditional PODs, or POD traditional here in the slide. And there again, you have a distribution of values because we have databases with lots of animal studies per chemical. And rather than deciding which study was most important or most relevant or what biologies to include or exclude, we took them all. We put them into a distribution and took the 5th percentile as essentially a threshold dose on adversity. And data contributed were largely from our toxicity value database at EPA here. This is a database that was presented on in this community of practice several months ago by Richard Judson, who's the lead scientist on it. But values were also contributed by Health Canada, ESSA, and ECA. This really was an international effort. So comparing those 2 distributions, we get a POD ratio. So we can decide how often the POD-NAM was equal to or less than the POD traditional. And then the second step was deriving this bioactivity exposure ratio. In older terminology, you might think of this as a margin of exposure, but for prediction methods for NAM. So we're predicting POD NAM to information from EPA's ExoCast program. If you're familiar with it, this was specifically the SEAM2 model that was published in 2014 because we did this work prior to the release of SEAM3, which is now out. And we also had exposure information donated by Health Canada to try to ground truth for some of the chemicals, how relevant ExoCast predictions might have been from that SEAM2 model. So we can ask these questions. Is the bioactivity exposure ratio useful for prioritization? Are there weaknesses we can address? And is the log 10 POD ratio less than 0 for most chemicals? So essentially, is the POD NAM less than the POD traditional most of the time? Because if it is, then it would have been protective for what we learned from animals. You might expect that the POD NAM would be less than the POD traditional because in vitro, we're not necessarily defining adversity, whereas in the animal methods, typically they'll find the dose where there was some adversity and then calculate NOAL or BMD from that. So you might anticipate that we would have some left shifting of the POD NAM. All right, so this is a figure from the paper. There's no humanly possible way you can read it. I'm going to break it down so that you get what you need from it. On the left-hand side, there's this large rectangle, and the y-axis is chemical. So we had 448 chemicals for which we had all of the information necessary to do this case study. And then on the x-axis is dose on a log 10 scale. So it's log 10 mg per kg body weight per day. And then I have these red boxes that are blown up to the right in panels A, B, and C. And what I want you to see is just kind of like a magic eye, so bear with me. So on the left-hand side, there are these gray dots all the way over. That's the upper limit of the exposure prediction. And it's great that that's less than the other stuff, because typically you want exposure to be less than any prediction of hazard, right? So good. Those exposure values are typically to the left. And then the green values are the POD NAM, and the dot is essentially the lower bound estimate on the POD NAM, and then I have a trailing line to kind of show a range that's discussed more specifically in the paper. So you can see those kind of vary and cascade down. Some of them are closer to exposure than others, which is interesting. And then the blue squares here that are mostly to the right, and then they kind of shift a little closer and closer to the POD NAM, those are the POD traditional. So down here in this lowest red box that's blown up as panel C, that is where the POD traditional is actually less than the POD NAM. And this is interesting for us to consider because, well, why wasn't POD NAM conservatively protective in this instance, and what can we learn? So I'll spend a little bit more time on that. Globally, though, 90% of the time almost, this naive approach that we took appears conservative. So like 90% on anything I think is pretty good. I think that means that we have some tweaks we can make, but that there is value in taking this NAM-based, risk-based approach. So we'll spend some more time talking about the 11% of the time where that POD NAM was actually greater than the POD traditional and why that might have occurred. This is just to break down that log 10 POD ratio a little bit more for you to show you that the POD NAM is generally conservative, but that it's also adjustable. And unfortunately, in the interest of time, I won't go into many of the details here. The distribution to the left gives you a little bit of information about what we found. So on the x-axis here is that POD ratio. And when we use the POD NAM 95, which was the lower bound estimate of POD NAM, you can see that the median difference was about 100-fold between the POD NAM and the POD traditional. So on average, we were about 100-fold conservative. But there was a whole distribution there. And if we've made different choices in our POD NAM distribution, we can actually shift those values to the left and then our median POD ratio would be about 1, which would be about 10-fold difference on the log 10 scale. And the different choices here relate to choices in toxicokinetics. So we're using the HGTK-R package, and one of the really great things that it does is it uses a Monte Carlo simulation to evaluate inter-individual variability. And so we can take the most susceptible individuals, which would be that POD man 95, or we can take a median individual. And you can see here that changes our POD ratio distribution by 10-fold when we make that one choice. So we're trying to show that there is tunability here to the amount of uncertainty that you want to include. We also want to show that essentially in the NAM-based methods, we can explicitly account for what kinds of uncertainty we're looking at, and they actually have some basis in a model or in some math. So I want to get back to this panel C that I mentioned, where the POD NAM is actually greater than the POD traditional. And you could think of some questions like, well, maybe there were some in vivo toxicity types that we didn't have coverage for in ToxCast assays. So it could be a biological space issue. Or maybe there are certain study types that are difficult to predict from bioactivity. So you could have some hypothesis like maybe we don't capture chronic toxicity very well in vitro assays or something like that. So this is a little bit deeper into the forest, looking at the trees. We did a little bit of work looking at enrichment for what kind of study type drove the minimum point of departure for the traditional points of departure to look at this question of, well, was bioactivity protective for instances where a chronic study drove the minimum POD? Was bioactivity protective for instances where developmental or reproductive studies drove that minimum POD? This was our way of accounting for, was there some sort of biological space bias in that panel C? Were developmental toxicants overrepresented there? The answer is no. Were chronic toxicants overrepresented in that space? The answer is no. So it really didn't seem like it had to do with study type, where we're using study type as essentially a surrogate for phenotypes that could be observed. So in a developmental study, you would observe potentially developmental effects, and in a chronic study, you could observe things like carcinogenesis in an animal model. And it didn't seem like this biology was affecting our ability to be conservative for the POD traditional. But, interestingly enough, chemical structure did have something to do with it. We wanted to understand when the POD NAM was greater than POD traditional, was that driven by some specific chemical features? And it turns out that, yes, in a lot of instances, it was driven by chemical features associated with organophosphate pesticides and carbamates. And actually, if you're familiar with the thresholds of toxicological concern, or TTC, that's a structure-based approach to estimating a threshold for hazard. And they would actually have a workflow for assigning a very low prediction for these structural features. And so this is something that the toxicology field is already familiar with. We say, oh yeah, those should have really low thresholds. So that said, there's a lot more detail in the paper, and I would encourage you to look it up now that it's online. So we have a sense that a NAM-based POD can be protective of an in vivo POD nearly 90% of the time in our case study. And in the case study, we actually go into more detail in comparing that to then the TTC and how we did in comparison to TTC, since that's an existing NAM that's structure-based. So let's look at how prioritization would work. And this is really talking about the bioactivity exposure ratio. And again, here I have a somewhat complex figure, but what I'd like you to take away from it is we're showing 4 different cumulative frequencies for BER because we calculated BER 4 different ways, which means I can make a lot of different choices to impact how much uncertainty I fold into my estimates of risk, right? So I can calculate the BER with the most sensitive individual from HGTK and the 50th percentile from the exposure distribution. And I can do that, again, for the 95th percentile on the HGTK and the 95th percentile exposure. And I can basically adjust my exposure risk that I'm including and my hazard risk that I'm including and calculate this even more than 4 ways. Okay. The way that we believe is kind of the most conservative and most basic way to do it is this black line, where we make the most conservative assumptions for exposure and for hazard. So you can see I've labeled like this is more conservative and this is less conservative. So we're putting more of the uncertainty into our estimates here in this black line. And you can see that, looking for a BER of 0, so where bioactivity and exposure equal each other, we're not really prioritizing a whole lot of the chemicals in our case study. It's still less than 10% of the chemicals would be considered kind of interesting based on a BER of 0. So you might ask yourself, did exposure or bioactivity appear to drive that BER-based priority? Which was more important? Was it really low bioactivity values, or was it really high exposure predictions, or some combination? And so this distribution attempts to answer that a little bit. I'd say on average, these chemicals that are labeled are the ones that had a BER of 0 or less, meaning that exposure and hazard overlapped in our estimation. And you can see that they tend to have kind of lower POD NAMs. They tend to have lower bioactivity predictions, which means these are things we could follow up on. Toxicologists could look at all of the ToxCast data for these chemicals and maybe refine some of these estimates. They also, some of them tended to have less than the median STEAM2 95th percentile, but then some really were higher exposures, like the phthalates. So there was a mix of things going on that drove our risk-based priority. So conclusions and limitations. We think that this approach to using in vitro bioactivity data in the aggregate to define a threshold for bioactivity appears to be a conservative estimate about 90% of the time for the 448 chemicals that we looked at. In general, this margin approaches about 100-fold if we make the most conservative choices in our workflow. POD NAM may provide a refinement of the TTC approach. I didn't show you any of that. It's in the paper. But essentially, the POD NAM tends to be greater than the TTC, but less than the POD traditional. So maybe it's getting us a little bit closer to a reasonable threshold value. And then when combined with high throughput exposure estimates, I really think this is a reasonable basis for a risk-based prioritization and screening level risk assessment, with obviously opportunities for refinement based on higher tier information. And then we learned some things. We learned that specific types of chemicals may be currently outside the domain of applicability, not only due to assay limitations and the types of assays we run, but also maybe some chemical structural features where we don't capture that specific biology, like acetylcholinesterase inhibitors and how potent they might be in vivo. So how do you identify these in the future? Well, we can apply some combination of a structure-based approach like TTC and bioactivity, but there may be other classes that we're unaware of because we look retrospectively. It's that light post effect of you find what you're looking for. And I believe this is the largest retrospective look at this to date, but what if new chemicals perform differently? What will be the prospective approach? So that's where we go next. What about the new chemicals and the data poor chemicals? So I just want to briefly outline for you what our intentions are here in this case study, looking forward to chemicals that do not have a complete in vitro or in vivo matrix. So step one is identify these substances with limited information that are data poor. Step two is completion of a NAM battery for these 200 substances, and this includes high throughput transcriptomics, phenotypic profiling, immunotox assays, acute neurotox assays, developmental tox assays, endocrine relevant assays and models. And of course, the high throughput toxico information that will allow us to do that in vitro to in vivo extrapolation of dose. So we're making progress currently on steps 1 and 2. This heat map to the left is essentially the NAM data matrix, and this is where we started last year, and we're trying to make this one big blue square where we fill in all of the data that we're missing. And a key element to mention here is that we're really interested, once this data is completed, in identifying chemicals that have a bioactivity exposure ratio of less than 10,000. We don't really want to look at chemicals that you would never be exposed to, where the bioactivity and exposure will never approach each other. Step 3 in this workflow would be actually testing in a 5-day in vivo study. So the idea is we might select up to 20 substances from the NAM-based approaches to then put into a short-term animal study. That would include transcriptomics in the liver. And this would be essentially a confirmation of hazard information, the MOA perhaps, as well as what doses are adverse. And then ultimately, we might take a few substances to a 90-day study in rodents. And of course, there will be a learning step where we evaluate how well did this work, did we pick the right substances, were we able to confirm or deny what we found in vitro, how would this work? And right now we're working on some early selection for that 5-day in vivo testing, and it's largely based on the BER as the first step. And then I always look at the analytical chemistry for those chemicals, i.e. were they within our domain of applicability for Toxicast? Were those data poor chemicals? Do they fit agency interests? And then what are their bioactivity indications? So kind of like hazard flags for things like developmental toxicity, for example. And in this case, it's still a manual deep dive as we try to identify what programmatic rules would be. And then we can do some other refinements, like for instance, which candidates might be better candidates for read across and for further testing and things like that. So we're really trying to create a workflow for doing this in a naive situation. So conclusions. A major premise of both case studies is that a threshold concentration corresponding to global in vitro bioactivity is likely to be a conservative threshold for any biology or toxicity that's observed in vivo. And that's a big assertion to make, but that's where we're going. And we think that BER may be a reasonable data-driven metric for prioritization, given especially that this is a metric that is adjustable to the amount of explicit uncertainty you want to include. And we think that the prospective case study will go a long way in furthering confidence in identifying limitations. I think it's a novel thing to do and a very interesting one. And finally, these international considerations I think are really important. So the regulatory framework in Europe is not the same as the US, and it's not the same as China or Singapore or Brazil, and yet we have similar exposomes. The exposomes vary too, but in terms of reach and management of chemicals in Canada and the chemicals that we're looking at, it's not like we have unique universes of chemicals, but we have unique regulatory challenges. So I think these case studies will help apply these data. Everyone has access to Toxicast, but how will we all use it? And these are sort of more global conclusions, and I might flip back to Maureen here so that she can make some final comments too. Basically, at a very high level, we think this is a more rapid and inexpensive route that we're embarking on. We think that this is important for risk-based assessment. Uncertainty analysis of NAMs is obviously going to be really important going forward, and how much uncertainty we're including at each step. And databases and data curation are clearly integral. So the data we're pulling on in vivo studies, that's curated, right? And so building those data sets is actually really important for ground truthing our assumptions. And the data management systems and decision support tools that will be built on top of that are also going to be fundamentally important to making weight of evidence decisions. So with that, I might flip it back to Maureen. Do you have any additional comments?
Not really. I think overall, I mean, you covered a lot, and I think these case studies are sort of the poster children for showing how, what we wanted to get out of APCRA, to show this collaborative effort and what we can gain as far as the development and the implementation of NAMs. I would also say that the list that you had on the previous slide where it talked about the different areas that we need to, what we found in sort of bringing these groups together is that people were starting to work in these areas in some cases anyway, particularly looking at databases and data curation and data management, and so trying to collaborate and, pool our resources and our efforts so that we're not all doing the same thing in separate silos. And so that's one of the directions moving forward as well, not only with the development of the NAMs, but also sort of managing the data and how to move that forward. So, but that's all I think I had to add. I think you've covered a lot.
Thanks. Well, thanks everyone for your attention. I want to acknowledge all the people here at EPA and NERL and NHRL and NCEA and NCCT, and we're soon all to be jumbled into new organizations, but the people are all still here, and thanks to all of you, and particularly to Rusty Thomas, Jason Lambert, Grace Padalich, and John Wamba, who provided technical insights and great support of this work to date. So thank you.
Great. And yeah, now we can open up the floor for questions. So anyone, if you have any questions, please let us know in the chat, and then I guess we'll also just open up, see if there's anyone in the room who has any questions.
Just one, this is Paul Price for people on the phone. Just one of the observations in there is that you do have a jumbling together of uncertainty and variation, that the distribution of the scene median estimates is all uncertainty. The PODs from animal studies and the in vitro studies is sort of a little bit of both, and the variation in the PBPK predictions is all about human variation.
Right.
So when you put together these comparisons, you really would like to keep those cleanly separated or at least acknowledged, and that could be an area of additional work in the future.
Yeah, that's a great comment. So for those of you on the phone, if you couldn't hear all of it, Paul was commenting that a number of our metrics, I guess I'll call them, have uncertainty that can be variation or actual biological uncertainty or prediction uncertainty, model uncertainty, and it's a little bit jumbled together. And that's true, and we actually do have some ongoing work looking at how do we essentially line up existing uncertainty factors and how they're used in risk assessment to a NAM-based uncertainty factor, and so that is an area of continuing work. I think it will be important so that there's a little bit direct translation between the current sort of red book process of risk assessment and what we are proposing.
Cool. And also we have a few in the chat now. We've got one from Sergio Villalobos, and they want to know, can you provide the details of the Friedman et al. 2019 reference? Will there be a case for eco-risk evaluation in that paper?
That's a great question. So we did not do anything ecologically relevant in that Paul-Friedman et al. Paper. I don't know, are the slides shared publicly after?
Yes.
Okay, so the DOI for the paper is in one of the early slides, but it's all human health focused. So the POD traditional values that we included came from mammalian species that are used in human health risk assessment, predominantly dog, rabbit, rat, and mouse. So we don't have something that's like, we don't even have the terrestrial mammals that would be considered an eco-risk assessment, and we certainly don't have aquatic life and biota, things like that. But there is another case study in APCRA that is working on essentially the same approach, but using eco-relevant data from fish and some other models as the basis for the POD comparison instead of mammalian-based type risk assessment.
And then we got one from Catherine Mahoney, and they want to know, in the absence of ToxCast data, what do you think will be critical to include in an in vitro bioactivity screen?
So the approach that we're taking in the center here is to develop quote-unquote global technologies. So Josh Harrell and his lab are developing high-throughput phenotypic profiling methods. It's a high-content imaging screening of multiple cell types to try to understand essentially a threshold for change in different subcellular compartments, right? So that's sort of a global cell-based screening that is very resource efficient and can be done for a lot of chemicals rapidly. So that's one type of method we're developing, and those data will be in the prospective case study. Another methodology also here in the center and in Josh Harold's lab, and a number of people working on these data, is high-throughput transcriptomics. So trying to do a quote-unquote whole genome transcriptomics experiment in different cell types. And that's something that is coming online here, as well as other places. So in place of the more targeted ToxCast assays, I might recommend some of these Tier 0 or Tier 1 approaches, and then following up with a lot of the types of technologies we had in ToxCast if those indications are needed. I hope that helps answer your question.
And I don't see anyone typing right now. Yes, I got a thank you on that question. And we've got, it looks like Sergio is also typing, and also a thank you.
All right.
So I would say unless we have anything more in the room, we can probably start just wrapping this up then. Speak now or forever hold your peace, unless you just want to send an email later.
I can send the PDF. PDFs for everyone. Reprints for everyone.
Yes, and the slides will be up on our website probably just later this afternoon as well.
Yeah, and since I just corrected the proof yesterday, I think the PDF may be a couple of days before it's corrected online, but you can look at the accepted version of the manuscript online.
Cool. Well, I guess with that, I just want to say thank you to everyone for joining us. Be sure to join us next month where we'll be hearing about the NCATS bio. Goodbye.
The leader has disconnected.